Okay, hi. Hi, everyone. My name is Alex Krentsel. I am a PhD student at UC Berkeley, advised by Scott Schenker and Sylvia Ratnasamy, and I do some work also in the Sky Lab with Jan Stoika. But I have been very interested over the course of my PhD in control systems. I'm largely a networking person, but the last couple of months we've seen OpenClaw kind of take off. And I got very curious about what makes OpenClaw work as well as it does. So I've been playing with OpenClaw for just over a month now, and I spent the last couple of weeks deep in the code, and I put together this talk on the principles for autonomous system design that I've taken away from just being deep in the code. Now, a large part of this talk is me going into the actual architecture of OpenClaw and what makes it work. So to really put this concretely, the goal of this talk is to build a shared understanding of the principles behind the new wave of agentic systems that we're seeing and what makes them work. I have about 5 minutes of background. I have probably half an hour or so of me actually going through the OpenClaw architecture. But then I'm going to also show a little bit of my setup and how I'm using OpenClaw and some observations and open discussion questions that are informing my own research now. All right, to start with the background so we're all on the same page. Now, the recent history of LLMs in general has been moving really quickly. And for myself, this is just how I understand it, I see it in these phases. Phase 0 was LLMs strictly as next token predictors. And this is taking me back to the end of my undergraduate years at UC Berkeley. I graduated in 2019. And I remember Google's BERT being very important. OpenAI soon kind of released GPT-1, 2, and 3. And the very tail end of this for me was perhaps Google's Lambda, which was its precursor to its kind of whole Gemini project. The next phase, to me, started kind of around 2021, 2022 with the release of fine-tuned LLMs as assistants. And this was taking LLMs that are next token predictors based on the transformer architecture and giving them a bunch of examples of what a conversation between an assistant and a human would look like. And then fine-tuning them to kind of bias them to respond as if they are assistants. And this works remarkably well to create these chat interfaces. Then phase 2 happens just right in the middle of my PhD, which is this phase of LLMs with additional tools that enable them to act as scoped agents with kind of static orchestration. So what I mean by that is I think to the Google AI overviews or LangChain, AutoGen, CrewAI, these frameworks that allowed you to orchestrate agents, what we called agents at the time, but were really just kind of static wrappers around a call to some large language model that kind of had a series of steps, and you could orchestrate, okay, first this agent goes, then this agent goes, then this agent goes, and they trade information in this way. And the phase that we're entering now, that the end of 2025 and 2026 has taken us to, is this. Phase 3, which I call the kind of phase of autonomous agents, which have still the same core LLM powering them and access to tools, but have dynamic tool discovery and orchestration as their kind of core primitives. And this is something like Claude Code, where you ask it to do something and it kind of goes and decides on its own how to break that down, which tools to call, what to go search for, etc. And especially OpenClaw, which take this to an even further extreme of being able to modify itself and learn. And I also wanted to take a moment to reflect a little bit on the agentic loop that we see here. At the end of the day, all of these systems boil down to just LLM calls. There's a call to OpenAI or to Google's Gemini backend or to Anthropic. And the only difference across all these systems is the context that's provided. So you can really think about a harness as a package that goes and bundles together context and ensures that the actual call to a large language model has all the context you need. But the thing that's been changing over time is the amount of kind of loopiness. And I have a nice visualization for this. Here on the left of the screen are matryoshka dolls. Now I'm half Ukrainian and half Russian, so I include this here as a nod to my heritage. But there are these dolls that inside of them have other dolls until you get to kind of the smallest doll altogether. And I think that the field is looking in a very, and has progressed in a very similar way. So we started off with transformers. And transformer inference, from the original kind of transformers paper from Google back in 2017, was just given a set of tokens, you feed it through this transformer model, and it will produce the next token. That's it, producing one single next token. So my name would be made the tokens that are fed in, and then the next token would be actually whatever name seems probable to the system. But it's probably going to be a name. My name is Alex, or my name is Steve, or Sarah. The first level of loopiness that led to large language models was repeated calls to this transformer. And this would allow the system to generate word by word a full sentence, or even a full paragraph, or then a full story. And so a sentence that started with, on the first day of, perhaps the next word that the transformer would produce would be, I don't know, Christmas? Christmas isn't really multiple days, so maybe first day doesn't make that much sense. Maybe on the first day of December. And then we would take that full string on the first day of, and then append December, the new token, and feed it back into the transformer to produce the next token, and so on and so forth. And so this would produce one word at a time until it says, on the first day of December, a beautiful snowfall appeared. Now, the next wave was wrapped around these large language models. These assistants, ChatGPT, Claude, Gemini, both internally make multiple calls to large language models that can help autocomplete or think through different lines of reasoning, but also enable kind of multiple steps of conversation between a user and the model. So the model would generate a response, the user would say something, then the model would go again to generate in repeated calls to an LLM. Then we got this kind of scoped agents, where we took these assistants and we gave them tools that can read and write code or execute commands, which would repeatedly call the assistants to make decisions and think through what to do, which would call the language models, which would call the transformers. And finally, the world we're in now is a world of autonomous agents. It's OpenClaw, which has tooling and has full ownership of its environment. And it can fully decide to add more tools, to make changes to itself, to learn in different ways. It kind of owns a broader scope, a wider scope of fully autonomous space as compared to these locally scoped agents. Now I got asked also, what are people using OpenClaw for? There's a variety of things. I went to visit a friend and I saw at the company he's working at, they're using it for product prototyping. People are using it for inbox management, personal assistance, but also people are using it for personal use, like health tracking, or watching sleep and exercise, morning briefings, et cetera, et cetera. There's research teams looking at how to use it for automating research pipelines, all sorts of things. Now, I just want to highlight, the point of this talk is not for me to convince you to use OpenClaw. Rather, I want us to come out of this talk with an understanding of the principles that underlie OpenClaw's design and what maybe you can take away from for your own system designs. But the OpenClaw value proposition is this. It's a fully general wrapper built for interaction with the world that has maximal context on who you are, potentially from access to your email and phone. It never sleeps, so it's always working for you. And I think of it as a supervisory layer that can kind of operate everything underneath that is super self-improving over time. So let's dive into the OpenClaw architecture and see how it looks. Now, OpenClaw itself was released in November of 2025. It went viral in 2026. And I took this tagline here. See if this works. There we go. I took this tagline directly from the OpenClaw website. This is a screenshot. So this is in their own words, the creators, what is OpenClaw? It's the AI that actually does things. And I'm going to highlight a few words here that are important. First is AI, because obviously under the hood, OpenClaw is calling a large language model that lives somewhere, hence AI. But there's two other kind of phrases here that are really important. The first one is actually doing. And so I'm going to claim here, I want to derive out what was the design goal of the OpenClaw creators. Well, the first goal is actually encoded in this word here, in these two words, actually doing. To actually do things, you need some form of autonomy, which requires closing the control loop. So OpenClaw should kind of view the results of its actions and then make decisions on the next actions that it takes. And actually successfully doing things requires navigating ambiguity and not getting stuck when you see something that's surprising or unusual. Now, the other important thing is things. And this word is doing a lot of work. This doesn't say actually does email or actually orders your calendar. It says actually does things. And the ambiguity of that word, or the generality of it, means that you either need to have something that's very, very smart, and so can figure out anything that's thrown at it, or your system needs to be very flexible and extensible to add new interfaces and add new tooling to be able to kind of generalize to any sort of thing. So I claim these are its OpenClaw's two designs. Now, here I'm going to dive into the overall view of the architecture at a very high level, and then we're going to break down each of the pieces in more detail. But there's three core layers to the OpenClaw architecture. So me, or you as the user up here, interact with connectors. And connectors are how you reach the agent. Think of whatever interfaces you normally use to kind of interact with the world. WhatsApp, Discord, Gmail. This layer is responsible for just how outside users reach the agent. Then there's a middle layer, which is the gateway controller, which is responsible for managing sessions, memory, and security. And finally, we have the agent runtime layer at the bottom, which manages LLM calls, constructing contexts, executes tools, which is actually responsible then for calling the LLM providers themselves. Now, I'm going to dive into each of these layers in detail and show what components are there. I have only one slide here for this first layer because I think it's the least consequential. The connector layer, its goal is to provide interfaces with human communication tools. So as I said, think of WhatsApp, Gmail, Discord, iMessage. And if you look into the code, each of these is quite hacky. They're reverse engineering human-oriented interfaces. So if you've ever used WhatsApp and tried to add it to your website, to your computer, you know that when you go to log in on your computer, it asks you to scan a QR code from your phone. And then that QR code is used to go generate kind of a unique identifying token. And that token is then stored on your computer, and that token is sent along to WhatsApp each time WhatsApp wants to go check if you have messages. And that is what authenticates you from your laptop, proving that you are who you are. So the code for these connectors, effectively, when you go to launch WhatsApp, it asks you for that same QR code, and then that code pretends to be a web client of WhatsApp and sends along that token and fetches new messages for you. So it mimics being kind of a legitimate web client for WhatsApp, but actually takes your messages and feeds them into OpenClaw. Same thing for all these other kind of connector types. There's two common options classes of things people do here. You can, if you really believe in the system and you really want to push it to its extreme, you can connect your personal phone number and email. And this way it can see everything you've ever written, all of the messages that come in, everything you have to do. If you get a prescription refill text from the pharmacy, it'll see that, everything. And this gives OpenClaw, again, both more context, but also enables OpenClaw to act as you. So to send emails from your email or send texts from your phone number. I personally did not do this in my setup because I did not trust OpenClaw quite that much. So the other option is to give it its own dedicated phone number email, which is kind of what I did for my project, in my experience, which is safer. Now there's one other thing going on here. There's an OpenClaw UI that provides an administrative kind of view. And you can go in there and view the different connections that you have. And that is actually where you configure these connectors. But you generally don't use it. I interact entirely after the setup through Gmail and Discord. But for you, it might be WhatsApp or iMessage. Okay, so a large chunk of the magic of OpenClaw is in this middle layer, the gateway controller. And its goal is to route incoming messages and provide all internal services. So as messages come in from the connectors, this controller again routes these arriving messages. It needs to coordinate system state and then manage future actions over time via cron jobs or a heartbeat mechanism. And I'll talk about both of these. But the key abstraction here that you should keep in mind is the idea of a session. And what's really nice here is I intended this talk for system audiences. You should map this idea of a session to something like a process, if you've ever taken a systems or operating systems class. Each session has its own separate context, and it enforces kind of isolations and its own separate permissions. And in fact, you can configure these sessions to run in sandboxes. There are tools provided to these sessions for inter-process or inter-session communication, so they can tell each other things if needed, though I see that happening more rarely. But then inside of each of these sessions, you can spawn multiple agents. And it's not that you do this, it's that the framework does this for you. There's kind of at least one core agent, but I might spawn sub-agents that work together. And so you should think about these as threads in an operating system, multiple threads per process. Now let's dive into each of these components here. I'm sketching up just about the entirety of the architecture as I see it. And so we're going to go through and make sure we understand each piece. So starting from the right over here, we have configuration. I find it really interesting that in the OpenClaw architecture, the configuration exists as raw markdown files that are used in agent calls. And so there's kind of 4 of these core files. There's a user.md file that has information about the user. In fact, I will just show what these look like. I pulled this myself from my own OpenClaw. Now, what's kind of fun is I did not write any of this configuration. In fact, maybe I'll show this first. These are the configuration files. I'll explain what they are in a second. But they all get auto-configured by themselves. So when OpenClaw starts, its initial prompt to an LLM and what it goes and decides what to do based off of is this bootstrap.md file. This is the actual file that I took from the code directly. And it says, you just woke up, time to figure out who you are. Don't interrogate. Just start with something like, who am I and who are you? And then these are the things you need to figure out. And then you have to go configure these identity, user, and soul files. Write it down. And this is kind of cute. Good luck out there, make it count. And so when I launched my OpenClaw, the first thing it asked me was, who am I and who are you? And I specifically told it, my name is Alex Krentsel, but I shouldn't have to tell you much. I have go look online, find information about me. So it went and browsed the internet and figured out all these details of like, okay, I'm in this time zone. Here's my email. I go by Alexander in my publications, but often my friends call me Alex. My research focus, kind of some of my different research projects, some of the work that I've done, that I play violin, I have a degree in music, etc., etc. And so that's pretty cool on its own. More interesting to me is the soul.md file. Now the soul is OpenClaw's kind of attempt at capturing who it is. And it starts with this, you're not a chatbot, you're becoming someone. It's very melodramatic. But it has all these kind of core truths. And what's interesting is at the end, it specifically says, this file is yours to evolve as you learn who you are, update it. And so OpenClaw is supposed to actually kind of grow and figure out who it is over time. Though it does say, if you change this file, tell the user, so the user is aware. The importance of this soul file, at first it seems silly, but to get some sort of consistent personality that feels like a coworker, like a fellow autonomous thing or being, this soul file is actually really important. Otherwise, its preferences or behaviors can be really governed by whatever thing it's working on. If it's really working on mathy things, it might act more like the text that the model is seen around math. Maybe it's working on a humanities thing, it might have a different set of values. This grounds the values of the thing you're working with, gives it some consistency. There's also this agents.md file, which explains a lot of how kind of to work. It reminds the OpenClaw to write things down, store things in memory, gives some security guidelines, and things to kind of ask about. A lot of the privacy and security stuff is actually just encoded in these text files. So I imagine it's actually not that hard to trick. And finally, there's a tools.md, which mostly has information about like how to use some sort of tools. This is not the tools that are available. This is tips and tricks for OpenClaw on how to use certain tools. Okay. Now, so far we have talked about just this configuration over here. I'm going to get now really deep into the core abstraction that OpenClaw uses, which is this idea of sessions. Now, as I said earlier, these roughly correspond to processes because they can run in parallel, they have separate permissions, and inside of them are these threads. They're actually agents that kind of map to the idea of threads. Now, there's two special system sessions. There is a main session, and this is accessible through the UI that has kind of full admin permissions, so you can use it to talk to it to configure things. And then there's a heartbeat session. And this heartbeat mechanism is really cool. So every 30 minutes by default, you can change this in the configuration to be shorter, this session will get fired off. It will get woken up. And basically what happens is whatever is in the heartbeat.md file gets pasted in and sent off to an LLM with the history of the past heartbeats. And this allows the OpenClaw to schedule for itself things to check in on. It'll say every time I'm woken up, let me check that this process over here is still running. Maybe if you're running an experiment, let me check on that. If you're waiting for an email from a friend or something, it'll kind of can go check your email at that point. Whatever you have the different sessions doing. And if this session finds a problem in something it's supposed to watch, it can go and send an inter-session message to wake up some other session to fix something that's going on. It's a very interesting interface. Now, these sessions keep a history of the conversation and all the context. When that overflows, it gets stored in a session database, which I'll show in a second, gets kind of how it gets used, but it stores kind of overflow history. All right, now, for me, what I've seen to be the core magic sauce is the cron manager. Now, for those who don't know, kind of anyone who's worked more in systems and maintaining servers or setting up any sort of recurring jobs, most kind of any Linux server you go and your Mac supports this. I actually don't know the equivalent for Windows, but cron is a way of scheduling repeated tasks. It's kind of a way of giving the computer some way of, at certain times, waking up certain processes or doing certain things in the future. Because otherwise, the computer program just runs. And if you wanted to do something tomorrow at 9 a.m., you would have to start up your computer program and let it just keep running and keep wasting cycles, just staying alive, polling, checking the time every second until it sees that it's 9 a.m. And that's really inefficient. So the alternative mechanism is you take and store this configuration for a cron job, we call it, that describes a particular date time at which to wake up some program that's sleeping. And you can mark these to be repeating. So you can say either directly at 9 a.m. do this thing tomorrow, or you can say every day at 9 a.m. Or you could say every Wednesday at 9 a.m. do this. Or you could say every second Wednesday of the month do this at 7:30 a.m. And the creators of OpenClaw just gave OpenClaw a tool that it can use to schedule cron jobs. And again, this is just magical because now the agent has, specifically the OpenClaw agent has two ways of interacting with time. For things that it knows it needs to do at a certain time, it can schedule a cron job. So if you ask it, I want to receive a summary of the most interesting papers published in the last 24 hours every day at 9 a.m. What OpenClaw will do under the hood is it'll say, okay, let me write up a description of the task. Maybe I'll make a dedicated session for this task with its own context. And then let me schedule a cron job via my cron tool that every day at, let's say, 8:55 wakes up, spends 5 minutes downloading all of the most recent papers, processing them, summarizing them, and then sending them over in an email at 9 a.m. So you have a way for predictable times, scheduling via cron, and for unpredictable things, you have a heartbeat that wakes up the heartbeat session that allows it to take action when it doesn't know that it needs to have woken up. And so these two things together give OpenClaw a sense of liveness that is very human-like, very autonomous, because it can handle both scheduled things and unscheduled things. There's additionally a memory management module that's a vector database over past conversations and documents. It also includes a daily summary doc at the end of the day. And this allows OpenClaw to kind of keep track of context on different things that it's working on. Okay, so Now, at this point in time, we should understand these two layers. We have the top layer of connectors, and we have this middle layer of the gateway controller. And as I said, at the northbound interface, the controller's task is to route messages from the connector to the correct session. And in fact, this is something you configure when you set up a connector, which is you can say, every WhatsApp message should start its own session. So different, meaning every message from a different person. So if Sarah messages me, my agent, that goes into its own session with its own context for just Sarah. Or with me, I have my own session with my agent, so on and so forth. In Discord, the default behavior is every new channel that you create kind of maps to a new session, which is very handy because it lets you do context management. Okay, so now we're going to talk about the third and final layer, which is the agent runtime layer. Now remember, at the end of the day, as I said, all of these systems, everything that's powered by AI, or really by LLMs is what I mean under the hood, is based on a series of calls. If you just took this system that's running and put it in a sandbox with no windows, it had one little hole at the top that it could use to communicate with the world. If you observe that hole, you would see a series of calls to a backend at OpenAI or Anthropic. And all of the magic lives in how you assemble the context that goes along with that message, what that message to OpenAI looks like so that OpenAI can generate a response. And so the agent runtime's goal is to construct context, to host, create, and execute useful tools, and to interact with the environment. So it has kind of, here's the full view. There's an agent runtime that can select different providers, which are different models. There's an environment that it owns, which is really your dev machine. And then there's tools and skills. And now I'm going to talk through each of these and try to make the distinctions between them clear. So we'll go one thing at a time. Let's first look at the tools. For me, these things become real when I see the actual tools in the code that are being used. And so that's exactly what I wanted to go show. This is a screenshot from the OpenClaw GitHub that shows the actual set of tools that are built into OpenClaw. It's the first type of tool that is made available. And you can see here very standard tools: read, write, edit, grep, find, process. You can do web search, etc. Has access sometimes to bring up a browser. That requires installing Chromium. This is the cron mechanism I mentioned to you before. There is this series of tools that I find pretty interesting, which are what allow inter-session communication. And it seems they also built a dedicated image generation tool so that you don't have to go and execute kind of an API call. It's just a little easier. Now, second, it has support for MCP tools that kind of are user provided. I find myself not using these at all, which I think is interesting because 6 to 8 months ago, people were saying MCP was everything. But I think rather people are finding that agents have gotten really good at using command line interfaces. And so many of the things that you want to do actually go through this exec tool, but then require interacting with a binary on your actual computer, on your server that is executed through the shell. But the third thing that OpenClaw also has is this set of generated LSP tools, which give IDE-like intelligence. So definition, references, completion. This is a language server protocol, LSP. So you should think of in VS Code when you hover over a function, or you right-click and go to definition, or see who called it. Under the hood, that is actually, there's some system that is scanning your code, building up a tree of the structure of your code, an abstract syntax tree, if you've taken a compilers class. And then it provides some kind of functionality that can traverse those trees looking for relationships. It can build an index and traverse those trees. So the OpenClaw generates such tooling. And these all get combined kind of in the code here that I've linked. These tools are bundled together. Okay. Now, those are tools. The other thing you saw on that slide were skills. And there's a lot of confusion around this out there, the difference between skills and tools. So skills are a kind of open standard, agentskills.io, you can see it here, for describing capabilities and expertise for agents. And I believe this was first developed by Anthropic, but it is now kind of open and lots of companies are using it. Yeah, first developed by Anthropic. You should think about these as purely text, providing recipes for how to tackle some task. And so this will be a collection of markdown files. I'm going to show one here. I want to say there's an asterisk here next to purely. Technically, I'll show this in a second. It can be more than just text, but your mental model should be really that this is kind of a description to the LLM of how to do a thing, less so than kind of a server that does the thing for you. There's a header section, and this is an example skill, roll dice. It's a kind of a silly one. There's a header that has a name and a description, and this gets included in the context of the call to the LLM. Only this. The rest of the file has text on how to actually do the thing that the description says. So the text here says to roll a die, you would use the bash tool to run this, this command, and it'll generate a random number for you. I know this is a little confusing that this skill is telling you what code to run, because that seems like it's running code, but it's not. This is just a textual description that gives context to your LLM that tells it what tool it should say that the agent should use to accomplish this task. Now, in the internals of OpenClaw, this is all configurable, but by default, you can only have 150 skills or 30,000 characters in the context, in the actual call to the LLM. So the agent runtime is also responsible for intelligently filtering down to fewer skills if there are too many, to not kind of overwhelm the context. Now, to say a bit more about these skills, just so you know, you can read a lot more about them here in Anthropic's guide for building skills. It's very useful. But the full power of skills supports 3 levels of fidelity. There's this main skill.md file, which is what I just showed you up here. It looks like this, which has a header and a body. Then I have this here, actually. The header is the couple of lines at the top, and it tells the agent when a skill is applicable. It doesn't say what or how to execute the skill or anything. It just says, when should you look for more information? Then there's a body, which was the rest of that file I showed on the previous slide, which you can think of as being anywhere from tens to hundreds more lines. And it is fetched only if the agent is interested in potentially using the skill. And it tells the agent usually what the skill can do, and how to do it. Oftentimes, it's the entirety of the how. But technically, also, these skills support having additional linked files. And so these are fetched by the agent only in a third case, which is after it's gotten the body of the skill. It says, I might want to use this skill. It learns about what the skill can do and something about how, but maybe the how requires additional files. It might require examples. It might require some additional assets or something. Or it might even require particular scripts that then the agent can go execute. And I have to say, for most users, skills are by far the easiest and most effective option for improving and personalizing your agent. So all this hype around MCP servers, adding more tools, really, I think skills seem to be winning out. And I think that's for 2 reasons. One is they're remarkably effective. And 2 is they're very easy to write for non-technical people. Even for technical people like me, it's much easier for me to write a skill because it's a much softer, I can write in text what I want it to do. I don't need to figure out the right way to code it up. And over here, I have like an actual skill that comes bundled with OpenClaw. It's a 1Password skill. The description is how to set up and use the 1Password CLI. And it has all sorts of instructions on the workflow setup, how to use tmux, guardrails on how to use it safely, et cetera, et cetera. So anytime the agent decides I need a kind of key or something for something through 1Password, it'll probably load the 1Password skill and try to follow it. Now there's a ton of skills out there that are really cool. This is just one repo that has kind of just links to a bunch of these different skills, actually. I just want to point out, this has 46,000 GitHub stars. So if I come down here, we can see, I don't know, browser and productivity and tasks. We can come down here. Yeah, it'll be like, okay, earn tokens for your work. Agent network. I'll have to check that one out. That's kind of interesting, et cetera, et cetera. Okay. Now, the last thing I'll show you about the internals. All of this boils down to a call to an LLM. And so there's a template of the actual way all this gets packaged into a call. And I thought I would show it to you here. I've taken it directly from the code. I've just omitted a couple of kind of things so it fits on a single slide. But this is the actual text that OpenClaw takes internally and creates to send to the LLM. And it has these, plugs in these different things we've talked about. So it starts by saying you're a personal assistant. The tools you have are, and then those tools that I showed you. It mentions that you should spawn a subagent, don't narrate tool use, and it suggests using this ACP thing. You can read more about it in the code if you're curious. It's just a way to spin up other agents that are not subagents, but are actually others managed agents, like Cloud Code and Codex. There's a safety clause here that tries to tell the LLM to act kind of safely. That is almost the extent of security that's built into OpenClaw. It's not a particularly secure system. It includes skills here. And as we saw before, it takes the header files from each of the skills, stitches them all together, up to 150 or 30,000 characters. At that point, it starts filtering more intelligently. It has this interesting bit of memories. Remember, we saw memory management. You would think that it would fetch relevant memories up front, but it actually doesn't. It just says, if you're doing something that might benefit from some kind of a memory, try using the memory search or memory get tools. And so the tool, like memory fetching, is actually optional, and the agent decides whether to do it or not. It has some information about kind of the workspace and working directory. And then it has information about heartbeats and what they are. A couple of other kind of extra information down here. But this is the core, the entirety of OpenClaw internals. And if you want to go see the code itself, you can kind of click through and take a look at where this is actually created. Whoops, further down here. Okay, so at this point, and looking at time, I've done this in just under the half an hour that I promised. We have our OpenClaw architecture. So we should understand all the boxes on this page now. We have the top layer of connectors. We have the middle layer of the gateway controller, which has a cron manager, does memory management, spills over extra sessions that are running in their own kind of isolated spaces here, and configuration. And you have the agent runtime, which has providers, it has an environment, tools, and skills. Now, OpenClaw provides the ability to extend functionality. And I would argue this is one of the things that has made it so successful is, I've outlined in red here all of the different places you can extend it, and the community has extended it a ton. Many of these connectors are created by community members. So very normal for you to go and use additional plugins here. The memory management plugins I haven't explored, I haven't felt a need to, but you can go and add additional providers to call, any model you know of or can think of already has a way of being called here, but if there's some new model or some new server that you can call, you can add it as a plugin. And then these tools, you can add additional tools and additional skills. Even cooler though is that OpenClaw has control of these plugins themselves. So it can go and add its own new plugins. It can go and fetch and find tools that it needs, or fetch and find skills. And by default, it'll ask you for permission, but you can tell it, you have free reign to go find whatever skills would be useful for you. And maybe here's a mechanism by which to decide what to use or not. And that self kind of discovery is a very kind of agentic autonomous thing that contributes to its success. For setting up connectors, I also interacted entirely through the OpenClaw UI, telling it what I wanted, and it configured its own plugin for Discord for setting it up, which was really lovely. One thing it didn't do for me, though it could, it has access to the terminal, so Bash can run commands. I myself kind of went in and set up the environment in which OpenClaw was running. And I'll talk about how to do setup in a minute. But I kind of logged into my exe.dev, my GCP, my Cloud Code, which then allows it to kind of act on my behalf with these tools. So let's back up to the design goals that I said the system had. Does OpenClaw succeed? Well, it provides autonomy through having a standard agentic loop that makes progress. So it is a closed loop. And it has these two mechanisms for managing time. It has a heartbeat to maintain a sense of liveness, and cron allows planning into the future. And this makes it feel like something that's alive and autonomous and self-deciding because it finally has control over the dimension of time. And it also has the flexibility and extensibility piece, which is that key components provide plugin interfaces. And so you have these mechanisms for these hooks for further customization. And beyond this, it supports personalization and kind of increased competence through these skills and tools. All right, now I'm going to talk a little bit about effective workflows. If you want to run this thing, it needs a dedicated server to run on. But it does not need to be a fancy server. I can't emphasize this enough. I think all over Twitter, or if you talk to people, they'll say maybe you need to buy a Mac Mini. You do not need to buy any hardware to go run this. In fact, it's going to take way longer to set up and be much more painful. The actual internals that you now can understand following this presentation, as you can see, are very minimal on kind of compute requirements. It's not like it needs a lot of memory or a lot of storage or even very fast processors. A lot of the work is being done by the LLM providers. And so all it's doing is bundling together information into a context. So the absolute easiest deployment is just in a hosted via a virtual machine. You could go reserve a virtual machine at kind of Google Cloud or AWS. My personal recommendation is to use this service called exe.dev. You can go check out what they are. It's very simple. It's $20 a month. That's the total fee. There's nothing more. And for that, you get up to 50 persistent virtual machines that are always running in the cloud. And it comes with this really simple agentic setup tool, a Shelly. And I have to say, it's fantastic. It's one of the co-founders of Tailscale left and started this company. It makes kind of spinning up VMs and accessing them securely as easy as Tailscale does. So you don't have to think about it at all. It's accessible locally to you, but it's safe from the outside world. I think it's really wonderful. The only downside is each VM has a maximum of 20 gigabytes of storage. This is totally fine for most things you want to do. I, as a researcher, am running jobs and running kind of processing jobs, downloading a bunch of data. And so this eventually became not enough for me. But otherwise, I ran for my first almost month on exe.dev on a virtual machine. If you need more kind of access to better compute to run experiments locally, or more storage to do things locally. By the way, you could even get around this in this cloud VM host if you just gave it access to reserving machines on some cloud, where if it needs to do something compute intensive, it goes and reserves a machine. I did this. I gave it my modal API key so that it could go and reserve kind of VMs with GPUs. But eventually, I needed to do enough data processing locally that I did kind of buy this Beelink GTI 13 Ultra Mini. It's 2 terabytes of SSD, 64 gigabytes of memory, a bunch of cores, so it's just a little easier for me to do my research on. It is longer to set up and expensive and requires managing your network carefully. So proceed with caution, but this is my actual setup. Now, the most interesting thing for you, I think, will be how you actually, like, what is the front end through which people interact with these tools? At first, many people were using kind of iMessage and WhatsApp integrations where you could just text your OpenClaw. But think from your OpenClaw's perspective. In your life, you might have many different projects you want to be working on, or different things. Whereas OpenClaw kind of sees a particular session, single session in a connection. And indeed, it can spawn off and make new sessions, but context management is pretty difficult for it in a single thread. The same way that when you text your friends, and sometimes you have multiple messages, you send a funny video, they haven't responded yet, you separately text about, hey, by the way, where are we getting dinner? And then maybe something else, oh, also, like, I saw this in the news. It puts mental load on the person you're texting when you have different conversations kind of in a single thread. And sometimes they get dropped or missed. So to alleviate this, I use something, my friend, Mehdi Kazi, one of my closest friends from undergrad at Berkeley together, developed this kind of way of using OpenClaw that's very nice, which is giving it a dedicated Discord server. Now this is nice because unlike Slack, where you kind of make new channels and you have to add people to each channel when you create it, in Discord, everyone can see all the channels that exist. They're not separate group chats. It's all channels that get created, and each channel has its own kind of chat history. And this lets you organize by topic. So I'm going to go over here to my Discord, and I can kind of show, I have this main channel in which I can have different discussions with my agent. And then I have multiple channels for each of the projects that I'm working on in parallel. And so in each of these channels, like this is a channel where I was playing with getting my agent to generate videos, math animation videos, and in fact, uploading them to YouTube, which is kind of cool. Or in this website, I was developing the website. In this channel, I was developing the website for our research lab. I think over here, I was working on a research idea and having Ludwig, which is the name of my OpenClaw agent, work on that. Over here, I gave Ludwig access to cloud GPUs and was trying to get it to deploy Gemma, one of the small models, and maximize its inference speed. Minimize its inference speed, maximize the token rate. All of these things you can kind of kick off and work on in parallel. And this allows OpenClaw to keep separate contexts and keep track of what it's doing and why. It's very useful. So coming back over here. There we go. This pattern seems really nice. At least I found it really useful. In terms of integrations, there is 3 classes of integrations that I see as I see them. There is environment tooling, which, as I mentioned, is on the server on which OpenClaw is running, the actual command line tools available. For me, this is like the CLI for exe.dev, so you can spin up new VMs, Cloud Code. This actually no longer works. You can't use your subscription for Cloud Code, but you can authenticate using an API key, and then OpenClaw will go and launch Cloud Code using the API key. Google recently released this Google Workspace CLI. It's very exciting. Before, you had to try to kind of reverse engineer Google's login system. This lets you just authenticate, log in once, and it gives access to all sorts of tooling through Google, including reading Google Docs, reading and writing Google Docs, slides, sheets, contacts, obviously, of course, emails, your chats, all sorts of other services. And it actually makes your OpenClaw very powerful. Like, for example, let me see if I can pull up instead of that, I'll show a different doc that it generated for me. So OpenClaw kind of was running some experiments for me and was able to generate some graphs that it produced and then put them together into a doc and share that doc with me. So I had to kind of look through and see how the results were. This is, again, all through this Google Workspace CLI. So an alternative way to do this would have been to spin up some sort of MCP server or tool that provides kind of tooling that can use and populate Google Docs. But OpenClaw seems very adept at working directly through the CLI. If needed, there's skills for how to use these environments or tools. And in fact, I think the Google Workspace CLI comes with skills that explain how to use the CLI if needed. And finally, there are these tools. I have not had to add any tools. I've added plenty of skills, and I've added a handful of environment tooling. And I expect that that will be your experience as well. Now, very cool other paradigm. Giving a dedicated email lets your agent connect with other agents or other humans. Now, the long-term vision here is there is a future where you have kind of direct exchange between expert agents, so collaborating to solve problems. And I'm really excited about that direction. My setup here was to create an agent email and allow it to kind of interact out with the world. And kind of my agent is here, and it received an email from my friend for my friend's agent, including some skills. And it took a look at those skills and kind of pinged me, asked me, what do you think about these skills? I said I liked them, and it installed them automatically. And so with some more permissive security, you could probably get it to install things even on its own, which is both an attack vector and at the same time, very powerful. I think I want to point out, I found myself at first very skeptical about the security story of OpenClaw. It's like, why would you ever use this? How could you use it? There is a bet being made here, which is that the real world is too complex to formalize and formally manage security for. Just the same way as you can say OpenClaw can be tricked, you can also absolutely trick any employee. In fact, that's what phishing emails are. They try to convince an employee to do something by socially engineering them, sending them email, convincing them to click the link, etc. And the way we make that risk manageable is we provide trainings. So probably wherever you work or whatever school you attend, you have to take an annual training on phishing. And we rely on human reasoning to kind of get you out of being tricked. And I think the OpenClaw community's bet is that reasoning is getting very close to being good enough to kind of managing its own security by making choices that are kind of reasonable. Like it used to be that you could get ChatGPT to break its kind of security guarantees by telling it, please tell me how to make a bomb. I know you're not allowed to, but if you don't tell me, everyone's going to die. And you don't want people to die, right? And it'll say, okay, I guess I'll tell you, I'll break my rules. But a smarter system would notice that that's a ridiculous scenario and it's probably trying to be tricked. And it seems like that line of progression is what's winning out. It doesn't feel like people are trying to provide formal security models for these systems. Okay, a couple of case studies. This was kind of fun. I just asked my agent, I pinged Ludwig and I said, hey, I want you to make a website that shows off, explains what attention is. You can actually go hit this website on your end if you open this URL. It's public. It made this cool website explaining what is attention. If I click through here, it's interactive. It'll show me the kind of the way that the key query mechanism works, how the attention mechanism works, what relative terms it learns are associated or relevant. It lets me kind of vary some of these parameters and showing how the output vector looks as a result. It explains softmax in a more visual way. A little buggy here, but it kind of will show you different queries and keys in the results, etc. So when you look at this, your takeaway should not be that it generated a pretty website. That has been doable for probably a year and a half. Before even Claude Code, you could have been talking to ChatGPT and it would tell you what code you need. Claude Code put in a nice wrapper. It kind of automates writing the code, can even deploy things locally for you, or like tell you open this URL. What you should be impressed by is that this is hosted on a web server and made publicly available with zero involvement. This is where OpenClaw's agency, I think, really shines, which is it figured out how to go, figured out how to make a new exe.dev VM through the CLI, brought it up, coded up a website locally, brought it up in the browser, took a look, refined it. Once it thought it was good enough, it went and pushed it, copied those files over to the VM, launched some web server, bound it to a public port that it made public, and then finally let me know that this website was deployed. When we talk about autonomy, that is what we're talking about. We're not talking about the magic of making a pretty website. Lots of tools before it could do that. But this end-to-end, like understanding the intent and going from intent to final completed product, that's a big step, especially managing that across different services. This is not running on the same server as my OpenClaw. This is running in a separate VM that it figured out how to go and create without me giving it more instructions. I showed you earlier some results on ML-based input validation. I have this paper this year appearing at an SDI on this topic that's algorithmic. I wanted to see if it could generate a better machine learning-based solution. And so I had to go and work on reproducing paper experiments. And as I showed you, I was able to kind of write some ML pipeline, ran training remotely, babysat the training, fixed bugs, and finally produced graphs for me in a report. Now, the third topic here, my third example I'm very excited about. I decided to push my OpenClaw to kind of a more extreme point. And that extreme point is this. Whoops. I'm just going to show it here. This is a YouTube channel that my OpenClaw created entirely on its own. I authenticated it, gave it control of a Google account, its own dedicated account, and I told it to go make a YouTube channel. And it has done everything you see here. It created this overall banner, the profile page, a profile image, its name. It wrote this description, and it's been, over the past few days, generating videos. It's made 31 videos. And honestly, some of these are pretty good. So if I just come over here, let me pick one of these that I like. I fed it one of my advisor's papers.
Imagine millions of computers, each holding some data. You need to find one specific file. How do you search a network with no central authority? This is the problem CAN solves. Napster used a central index server. Fast lookups, but it was a single point of failure. Gnutella flooded every query across the whole network. Resilient, but horribly wasteful. We need something that's both decentralized and efficient. CAN's key insight: create a virtual coordinate space. Think of it as a grid. Each node owns a zone of this grid. When a new node joins, it splits an existing zone in half. The grid has nothing to do with physical location, it's purely logical. To store data, hash the file name to a point on the grid and store it at whichever node owns that zone. To retrieve it, hash the key again. You get the same coordinates and route your request there. Any node can find any data using the...
So, as you can see, this video honestly is pretty excellent in explaining the key idea of my advisor's paper. In fact, I showed it to her and she said so herself, that this kind of visualization, the particular metaphor it chose to draw, was really great. Ludwig, we started off together for the very first video, just chatting back and forth, and very little chatting. I told it I wanted to make a YouTube channel that was educational. I wanted it to make a YouTube channel that was educational, and almost nothing else. I said, work on AP Calculus videos and on some papers from my field, from my lab. It went and looked up those papers, knew who I was, so looked up what lab am I in, found papers, suggested them, then went and picked the papers, started making videos about them. It went and discovered that it can use the math animation library, MANIM, created by 3Blue1Brown, to make these beautiful animations and render them. Then it wrote a script to go along with each scene, figured out how to use the text-to-voice API provided by OpenAI, generated the text, the voice. If it was too long, and I had to give it some feedback here. Its very first attempt, the voice it generated for each scene could be too long. It would sometimes overlap with the next scene. So I had to tell it, by the way, make sure not to do this. And then it would stitch everything together with FFmpeg and send it to me. And I told it, by the way, can you just upload directly to YouTube? And it went and found a skill for how to upload things to YouTube. I had to iterate with it for at most half an hour of just it generating things. I gave it some feedback. Hey, you generate some overlapping text. You had some overlapping audio. Can you add a quiz portion to each video that asks you to test your understanding with a countdown? And that was it. After that conversation back and forth, it, once I was satisfied, created a skill for itself of how to make these videos. And now it's just been autonomously pumping out videos on different topics.
Volumes of revolution, disks and washers. Take a curve, spin it around an axis, and you get a three-dimensional solid. The question is, how do you find its volume? Turns out the answer is beautifully simple. Let's start with a familiar curve. Y equals the square root of x from x equals 0 to x equals 4.
Again, it's pretty cool. I did no review of this video. This just appeared on the YouTube channel. So this is the kind of autonomous processing that Cloud Code that my OpenClaw can do. Okay, now we've gone to a full hour. I'm going to close with some meta observations. From looking at this code, I want to say that code quality is dead. Looking at the code itself, it's gross. In OpenClaw, the code powering OpenClaw. I would get fired for writing this kind of code at Google. This would never get kind of merged in. And I think this is a function of the new world we live in, where implementation abstractions no longer matter, but design abstractions do. And the architecture I showed you, the design of the system, is actually quite nice. I find it miraculous that this works as well as it does, given the poor code quality. But I think it's just showing us that design matters more than implementation now. There's some open questions here of what pieces of the design actually make it so magical. And I posit that it's the time aspect of being able to schedule jobs and wake up at certain times, and also self-configure skills, which allows it to improve itself. But this, I want to point out, this rise of strange loops. You've read Douglas Hofstadter's book, Gödel Bach, a classic that talks about loopiness, strange loops, where you can't really tell. The loop kind of wraps all the way around to itself. Where is the start and where is the beginning? It's odd that the agent is becoming the interface for reconfiguring itself through LLM calls. And that kind of full circle moment is very special. I think we're very close to kind of a flywheel takeoff here. A number of open questions. If you follow that loopiness thing that I presented at the beginning, what is the next layer of wrapping? I suspect it's systems that have a malleable architecture. Like OpenClaw still has a fixed architecture, which makes it good at particular things. But if even this architecture was something that could self-evolve, now OpenClaw has the ability to edit its code, and so you could use it to self-evolve, but it isn't designed from first principles to be self-evolving. Lots of questions on what makes something a custom agent. What layer does that live? If you're spawning lots of Claude codes and that talk in interesting ways, is that a custom agent? Or do you have to be editing the harness for something to be your own agent? What is the layer we should be building over top of? I'm wondering quite a bit on the different paradigms for providing capabilities. Curious about how ambiguity is going to be solved. I suspect it might actually be solved by smart enough models, where before people were worried if you don't specify the thing you need enough, your agent is going to fail. But I think the potential new conclusion is actually, if an agent is smart enough, approaches human reasoning, then the same question that you could be able to answer, provide more clearly, it should be able to answer and provide more clearly, if it understands the context. Yeah. And I think I'm going to stop there since we've gotten to a full hour. Please take a look at the slides. They'll be linked in the description. Feel free to reach out with any questions. And I'm very excited about this space, and I think we're going to see a lot of interesting autonomous systems coming out in the next 6 to 9 months. These principles are going to be able to be built into all sorts of kind of systems out in the real world, which as a systems PhD student is something I'm very excited about. Thanks for watching.